And I'll share my screen, excuse me, and we'll get underway. Okay, so really I'd like to thank you all very much for taking time out of your busy schedules to attend today. There are many of you that I do know on the call and many of you that I don't yet. For those of you that I haven't met before, my name is Jeff Morgan. I'm a principal at Hassel here in our Sydney studio, and I'm chair of MECLA's Aluminium Working Group. I'd like to begin today by acknowledging the traditional custodians of the land on which I am today, the Gadigal people of the Eora Nation, and pay my respects to their elders, past and present. I'd also like to extend that respect to any Aboriginal or Torres Strait Islanders peoples on the call with us today. As you can see, we are now holding the last of our 3 deep dive sessions with the key components of the construction and aluminium ecosystem. MECLA was founded in April of 2021 to address the issue of embodied carbon in the built environment. MECLA is really all about collaboration across the entirety of the supply chain to find solutions quickly. Currently, we have over 140 members and counting, and our purpose is to accelerate the decarbonization of the construction sector. By pooling knowledge and expertise from across the supply chain, we can really speed up decarbonization in these typically hard to abate industries. Importantly, MECLA does not tolerate any anti-competitive behavior. So if you are aware of any conflict of interest, please speak up so that we can adjust our actions accordingly. The purpose of today is really twofold. Firstly, we would like to share our working group's knowledge gained in the past year and a half of engagement, research, and discussion. And secondly, to hear from you what your experience, concerns, thoughts, or otherwise may be. And I'd also really like to extend that to our own working group members on the call with us today. So, as you're probably aware, the discussion around embodied carbon in concrete and steel is a much more advanced and well-known topic in our circles, but with aluminium, much less so, I think. I know as an industry, um, we often seek competitive advantage, but the challenge here is significant and the impact's even greater if we don't do something about it. So I'd ask that you all join today's session and discussion with an open sense of generosity and collaboration, a view that I've shared by Karen Coker at Arup that I've happily lifted several times now. Um, I'm also sure that there may be many different views and opinions expressed here today, or at least I hope so, and that really is okay. Today is about hearing and learning from each other on a topic that I'm sure we can all agree is an important challenge to address. So 6 weeks ago, we held our first deep dive with many of the main contractors and facade subcontractors to better understand their experiences and insights. It was a really great first session that dispelled a lot of the myths out there, and we're looking forward to sharing some of those insights that I think you'll find both interesting and helpful. And 2 weeks ago, we had our forum with an excellent cross-section across the various consultancies of architecture, facades, and ESD consultancies. Again, a lot of interesting perspectives through the consultancy lens that feed into some of the observations we'll share with you a bit later. And today, I'm really pleased that so many of you have accepted to attend today's session and hope that you all get something out of it. I know the invite has been kind of circulating around out there, so please don't be offended if you don't see your logo on the screen. But I do think it's important to acknowledge the breadth of companies on the call with us today and the shared ambition we have to help address the issue of embodied carbon within our built environment. So again, thank you for making the time today. The format for today will be fairly simple. I have some material to run through that gives an overview to the topics and highlights some of the key points from our MECLA publication on low carbon aluminium. This is, I suppose, really helps set the scene for the opportunities and challenges in our Australian context. We'll then be taken through a very informative case study by Megan Lorish from Lendlease on their own successful journey looking into aluminium and the complexities of large-scale facade packages, followed by some of the recent shifts in development in Australia, including some exciting recent announcements from our working group member, Michael O'Keefe at Capral. The last 3 points on the list are really a series of prompts for discussion at the end around the topics of procurement, including supply chain, modern slavery, and cost. And finally, I know these events can be a bit challenging sometimes to unmute yourself, but I would really appreciate it if we could have some good, robust conversations by the end of this. So I please encourage you to participate, and I'm very, very happy for you to interrupt me at any point along the way. Um, I had to correct this slide because I realized my maths was wrong. My own journey with aluminium started just over 14 years ago. I was working at Foster and Partners on Masdar. It was a visionary, sustainable master plan city for 40,000 people in Abu Dhabi. Whilst on one hand, I think you could probably question the project possibly on several levels, there were some amazing and interesting things that came out of Masdar. But one that really stuck with me was the fact that the project became the first in the world to use recycled aluminium for its structural facade extrusions. Prior to this, I think recycled aluminium had only ever been used in a sheet or panel cladding, which doesn't require the same properties and performance characteristics of the particular alloy. So, as a large owner and developer, Masdar used its own ambition and influence in the market to attract like-minded companies to push their own bounds. In this particular instance, Alcan, now owned by Rio Tinto, teamed up with a small remelt partner out of Belgium called Emax to develop their particular strength alloy that they needed for the facade extrusions. So that was 14 years ago, and I found myself asking recently, so where are we now? Um, in my work with Stockland on 110 Walker Street, I found myself asking engineers and contractors in the industry about the possibility of using recycled or low carbon aluminium facades. And really, to my surprise, I found that the conversation or opportunity was not as I thought it would be. Uh, something that I thought would have advanced quite substantially in that time apparently had not. And that ultimately led me to MECLA, where over the past year and a half, we've assembled a broad range of companies that form a part of this aluminium ecosystem, including architects, engineers, LCA consultants, miners, recyclers, remelters, contractors, researchers, financiers, and others. And we're all aiming to get a better understanding of the challenges and opportunities for a low carbon aluminium future in Australia. The group has had contributions from a broad number of people and companies over that time, but I'd like to highlight a few in particular that have been really integral to the part of this journey, including Matthew Finn at Arup. And for those of you that were at the NAWAC Awards last Thursday night, we have the winners of this year's award for sustainability, contribution to sustainability, Megan Lorish and Kiera Kenny. Megan and Kiera have really made some invaluable contribution to our working group, and I'm also so pleased to see their work recognized more broadly in the industry. And also for aluminium to get such a big shout out at the awards last week. We also have Josh Appleblom from Rio Tinto representing the mining side of things, which has been really interesting to see what they've been doing in this space. And on the call, we also have Michael O'Keefe to share Capral's industry-leading position and goals. And again, it's been really great to see the engagement and action from Australia's largest extruder in this space. Some of the others there, Blaze Porter from Sims Metal, one of the world's largest metal recovery companies, and Sebastian Lowenstein from the CEFC, or the Clean Energy Finance Corporation. His views on financing of kind of clean technologies has been really fascinating to this whole discussion. And also Chris McClung from Western Aluminium and Clive Fleming from Reclaim PV. There have been many others that have also contributed and continue to share an interest in the topic, but I'd also like to acknowledge their value to the group's journey so far. So what have we been doing? Since our inception, we've held 2 spotlight events through MECLA with key experts on the topics which are now available for viewing on our website. And secondly, the big thing that we did was we put all of our kind of heads together and published a document earlier this year, which is really a MECLA resource on aluminium for the development and construction industry, also now available for download from the website. This is really just a short 10-pager focused on the Australian context, and I think acts as a primer for everyone in the development and construction industry to begin the conversations around our ambitions for a low carbon future. So I'll now give a bit of a brief overview of the document, which should hopefully help set the scene for the rest of the session. So a question that's come up a few times in the previous sessions is what exactly is low carbon aluminium, or what do we mean by that term? I think low carbon aluminium is used to refer to aluminium with a lower embodied carbon content compared to current global benchmarks. Essentially, we use this term to refer to virgin or primary aluminium produced using renewable energy sources like hydroelectricity rather than fossil fuels. It may also refer to recycled aluminium, which has a much lower carbon intensity, which again can be made using either fossil fuels or renewables. I think the ideal scenario, though, is to have a product with fully recycled content produced using renewable energies, kind of as indicated on the far right-hand side of the graph here. Before I go on, I thought I might just pause here before I get into the kind of rest of the document. Does anyone have any questions or comments on anything so far? If not, that's fine. Okay, I'll carry on. Okay, so globally, Australia is a really very large player in the aluminium market. You may or may not know, but virgin aluminium is made by extracting bauxite from the earth. We then refine this into alumina, which is a white powdery substance, and then we finally smelt that into the aluminium. So as you can see on the slide here, Australia is the world's largest producer of bauxite in the world and the world's largest alumina exporter. Yet we're only the sixth largest producer of aluminium globally. I think we'll probably come back to this a bit later, but I think it's fair to say that there is a real opportunity locally for Australia in low carbon aluminium. And so why are we talking about embodied carbon of aluminium in the first place? Typically, aluminium is the third largest contributor to a building's embodied carbon footprint after concrete and steel. And compared to other primary materials used in construction, it is by far the most carbon intensive, roughly 100 times more intense than concrete. So yes, our buildings typically use much more concrete and steel in the construction, but there's still a fair amount of aluminium that still goes into our buildings that we need to work on. So as you can see on the graph here, for each ton of aluminium produced, approximately 14 to 20 tons of CO2 are emitted into our atmosphere. And why exactly is this? I think this picture probably gives it away. There are a few challenges around producing low carbon aluminium. The first being that it takes an enormous amount of energy to make it. Just to give you an example, in Australia, we have 4 aluminium smelters along our east coast. These 4 smelters consume nearly 10% of the national electricity grid capacity alone. That figure really, when I heard it for the first time, blew me away, and I think just puts into perspective the amazing amount of energy needed to make this material that we frequently use. And in Australia, the majority of this energy currently comes from our coal-fired power stations. Yes, thankfully our grid is decarbonising, and the recent announcements from 2 of our largest smelters at Tomago in New South Wales and Boyne in Queensland for large-scale renewables to power their operations will go some way into accelerating this change. But we'll touch on that a bit more again later. The other challenge is probably a little bit more complicated. As many of you know, the majority of the large-scale buildings and even many medium-scale projects that we work on have their facades procured from overseas in Southeast Asia or China. Over the past several decades, Australia has lost a significant portion of our manufacturing capacity and capability as a result of our current view that cost outweighs all other metrics. So the question is perhaps, even if we made our own low carbon aluminium up the road, how much of it would actually make its way into our built environment? It's a difficult challenge, this overseas procurement. And finally, the last challenge is ourselves as a development and construction industry. Advances in concrete and steel are much more broadly known, but the conversation on aluminium like we're having today is really only just beginning, and I think we've got some way to catch up. But now for the good news. Aluminium is infinitely recyclable. In our document, we have also outlined the opportunities for advancing our low carbon future, and there really is a huge opportunity. However, currently the linear economy really dominates the aluminium value chain here in Australia. We extract more bauxite than anyone in the world, and we export it. We produce more alumina than anyone in the world, and we export it. We do, however, import nearly as much aluminium as we produce, ironically. And at the end of its initial use, you've guessed it, we export it, approximately 95% of it overseas. If all that sounds like a bit of a wasted opportunity, it is. But thankfully, Deloitte and Corio have looked at the issue in really great depth in their recently published discussion paper for the Australian Aluminium Council, Cast Anew. This paper looks at the circular opportunities within the Australian manufacturing and recycling industries and outlines a strong case for opportunities locally. So hopefully watch this space. I think there's a lot more to come. One of the other great opportunities outlined in our publication is that recycled aluminium requires only 5% of the energy needed to make virgin aluminium. And certified recycled aluminium alloys are the technical equivalent of their virgin counterparts, exhibiting the same strength, properties, and finishing characteristics that you would expect from a virgin material. And despite the rumors floating out there, it can be anodized if the quality of the product is carefully controlled and certified. The other fantastic opportunity that we have is that it's estimated that 75% of all aluminium ever produced is still in use. You know, waiting for recovery, recycling, and reuse. Again, another really important opportunity as we transition to a more circular economy model. I'm sure that in the construction sector, the recovery of material from our demolished buildings is starting to mature, or at least it's much more mature than it was in recent times. But I think there is still some advancements we could make, particularly for the way we design for disassembly, or even how we consider the ownership models of our buildings and our assets. I'd now like to hand over to Megan Lorish from Lendlease, who will take us through their case study on the One Sydney Harbour project. Megan is the Regional Sustainability Manager in Construction and Development for Queensland and the Northern Territory, and was also deeply involved in the One Sydney Harbour project. Megan, I'm happy to flick through the slides if you want to
yeah, I'll
talk to
out when I need to change. Thanks so much, Jeff. My colleague Lee is also on the call, and he was absolutely integral to this work as well in his role as a facade specialist. A little bit about us before we sort of get into the One Sydney Harbour of it all. We set ourselves a target a few years ago to be 1.5 degrees aligned, which has sort of prompted these other two goals, which is net zero carbon by 2025 for our scope 1 and 2s and our 2040 target of absolute zero scope 1, 2 and 3. We've already achieved our 2025 target of net zero, and the work that this is kind of the lever, the 2040 target of absolute zero was the driver internally in the business for us to get green lights to go ahead and really push this opportunity through the business to try and get the low embodied carbon aluminium outcome. If we can move on to the next slide. Yep. The really important thing about the success that we had at One Sydney Harbour was that we actually had 2 failures previously. So the One Sydney Harbour development is 3 residential towers, listed here as Residences 1, Residences 2, Waterman's Residences. We tried on, and they're sequential. So we procure Tower 1, and then we procured Tower 2, and then we procured Tower 3. So we didn't procure as a whole of development approach. We procured each tower separately. And I'm pretty sure on the next slide we go into it in a bit more detail if you want to flick onto the next slide for me. Oh, no, we don't. That's all right. It'll come up. Yeah. This is just sort of talking about how we decided that we were going to target aluminium. So we had this 2040 goal of zero emissions by absolute emissions by 2040. Where do we start? What do we start looking at? And we decided that aluminium, there's already work happening in concrete, there's already work happening in steel. Nobody's really looking at aluminium. What are the opportunities in aluminium? And we did a bit of a market scan to understand where the most impact would be. You can see here our business as usual approach. I think it's something like 18 kilos CO2e per tonne of aluminium. So we really wanted to get this hydrocercal product, which was a 50% reduction. Turns out there were some barriers in getting that into Australia, especially with the way our supply chain is currently set up. At Lendlease, we tend to procure our facades as we go to one subcontractor and say, we need extrusion, we need glass manufacture, we need you to assemble it, we need you to install it, all in the one package, which typically means that we're often getting things extruded in China, panels made in China, shipped over here, put up on the building, which presented a lot of challenges because what we could get into China, into our extruders, was quite limited. The Hydro-SoCal project isn't available currently in the Chinese market, which means it wasn't available to us in our Lendlease current procurement model. So we went ahead in when we eventually got to a successful outcome, we actually had specified the hydro reduxia at the 40% reduction mark against our BAU case for carbon intensity. We didn't quite get there because, again, it's not available in the Chinese market. But what we did achieve was the 34% reduction Rusal allow product. So we set ourselves quite a significant target initially of the 50% reduction, and we ended up landing at a 34% reduction. It's not exactly what we're hoping for, but it also does represent, though, a huge step forward in what is available in Australia and understanding what the barriers have been to achieving getting these other products into our markets, into our buildings, and coming up with mitigation strategies for future jobs to get them over the line, which is what our next steps are. Our next projects are looking at, okay, how do we push this beyond the Rusal 34% reduction target number? If we can move on to the next slide. This is what I was looking for before. Yeah. So we started out on the first tower. We sort of came into the game a bit late. The procurement had already taken place for the facade, and we said to the contractor, hey, look, as an idea, would really love you to explore if you're able to use this particular product, being the Hydro-SoCal, 50% reduction in carbon intensity. And they came back to us and said, yep, sure, but it's going to be, I think it was a 10% uplift in cost, which was just unfeasible at the time commercially, given that the budgets had already been set, design documentation was complete. There just wasn't that kind of flexibility in the job at that particular point in time. Tried again on Tower 2, and they come back and said, you know what, this time it's actually going to cost you an extra $7 million. And we went, whoa, thanks, but no thanks. And we really struggled with the market at that point to get transparency on what was included in that $7 million. We never really resolved that. And unfortunately, we didn't have success on Tower 2 either. What we did ahead of Tower 3, learning from those particular failures, was reach out to our international colleagues. We know that the Lendlease business in Europe has had much better success in procuring low embodied carbon aluminium. They're geographically a lot closer, so there is a little bit of, there's less complexity for them, but we thought we'd reach out to them and just see what is happening abroad that will help us get to the point where we have success here. Which helped us sort of develop what their advice essentially was we need to get ahead of the procurement, which now you say it now and it seems so obvious, but at the time we were just two sustainability people getting really passionate about carbon intensity, not necessarily looking at the methodology and the way that our colleagues approach procurement and the way that the construction process works in terms of when the budget is set and when the design is sort of set in stone. So we went ahead and we got into the specification and specified the Hydro-SoCal, or the Hydro Reduxia product, which was, I think, at 40% reduction in carbon intensity. And so when the tenders came back from market, they included already the cost for procuring a low embodied carbon product. So it meant that we were getting responses from market that were already better thought out, that already had a strategy and an established or a proposed supply chain in place, and that didn't have crazy inflated prices attached to it. Which is how we got to where we sort of got success on the other end of this S-band here, was that we were able to move forward, having identified the Rusal product, which had an EPD, so we knew that it was a legitimate estimation in carbon intensity. We knew that it was a robust program, and we knew that it was legitimately a good option for what we were trying to achieve. yeah, so that was our success in that particular element. If you want to move on to the next slide. So the key findings here were early engagement, which as we sort of just discussed, that's how we failed on the first two towers, by coming at it after the point. When we had success, it was when we got ahead of the tender, ahead of the design, and started pushing it through very early in the concept of that particular tower. Persistence, it took us 3 towers to get success. We call all 3 towers success because we tested the market, we understood the barriers. By the time we got to tower 3, we had such a refined understanding of what our challenges were. We were able to go to market and say, look, we understand what the challenges are. We understand that also there are ways to overcome them, and we understand that it shouldn't cost an extra $7 million. We should be able to do it almost neutrally. And then number 3, making the question specific, clear, built for collaboration. We really had to work hard with our contractors to make sure they absolutely understood what we were asking them. We found that not many of our contractors were very educated in what upfront or embodied carbon meant, how to communicate embodied carbon. So when we talk about carbon intensities as kilograms per CO2e per tonne, understanding or helping them to understand what an EPD is and why we need to see an EPD, not just someone sort of, oh yeah, I think that's about the right amount. So really going on that education journey, collaborating with them, lending them our expertise, and really holding their hand through that process was absolutely key to making sure we got success. I think that's the end of our slides.
Yeah, thanks, Megan. Incredibly helpful as always. I know when your colleagues Michael and Vince were on the session originally with the facade and main subcontractors, that the feedback that they gave, because there were a lot of questions from that group in particular around this case study, also around cost. And they said, look, it didn't even really touch the bottom line. You wouldn't even bat an eyelid at it. There are quite a few raised eyebrows on the call, thinking, well, how can that be? Because I think your story really echoes the experience shared in that deep dive, particularly from Built, who were looking at the opportunities for the Atlassian headquarters. They were also told that low carbon aluminium was too cost prohibitive, and unfortunately for them, they only had 1 tower, not 3, and then found themselves that they didn't have the time within that single project to make it a reality.
It was so key to our success, having the 3 towers to learn and then immediately apply those learnings to the next tower. And I know that's a really unique perspective, but we're so lucky to have had that experience and be able to share the learnings now. And what we have found is that now that we've had one success, our pilot program has been successful. Our future pipeline of work, we're including it in our bids. We are procuring it on other jobs now. It is becoming, even in the years since we've had this success, it is becoming closer and closer to our BAU position. So it's been a huge impact to our carbon bottom line.
That's great. Before we move on, does anyone have any questions for Megan or Lee, who's also on the call?
Hey, Jeff. It's Shen here from Investor.
Hey, Shen.
I put a couple of the questions up on the chat, but Megan, that's good effort, by the way. I can only imagine coming in late and trying to procure aluminium locally here and somehow getting into your Chinese suppliers. It would have been just a nightmare. Just trying to understand, are you able to share the subcontractors who gave you, who you worked with at the end, as well as the ones that you didn't have much success with? Do you think this is not to shit can some subbies, but more just so I know who you've already approached?
Yeah, so
Lee, so we know who you've already approached.
Yeah, Lee can give you a lot more details about generally in the market who's where, but with us, we worked very closely with Permis-Delisa. So Permis-Delisa ended up being the successful contractor on all 3 of the towers. So they were the ones that came back to us with a 10% uplift and then $7 million and then suddenly cost neutral-ish. So it was a massive learning journey just for those guys on their own. Unfortunately, some of the other contractors we worked with just weren't able to get their heads around embodied carbon enough to really come back to us with a thought out approach and be able to cost it for us to have, security and comfort that they were going to deliver on their promises.
And then the other question was, you had a chart with the hydrocecal and a few other options, sort of 6. So are all of those Australian-based products with EPDs, or are they?
No, so these are all international products. We are currently really motivated in trying to establish a supply chain here in Australia of low embodied carbon. I mean, I'm sure the supply chains exist, but really trying to motivate or mobilize our internal procurement strategy to be able to mobilize those opportunities. Unfortunately, these are all international products.
And so the onus was on the subcontractor to source the supply chain for the raw material.
Yeah, essentially.
To then be able to produce the.
Because when we let a facade package, we expect that subcontractor will handle all elements of the facade, including extrusion. So when they're extruding, or they've got an extrusion partner in China, they're really limited to what is available in the Chinese market, what is available to that particular extruder.
You mentioned getting an EPD. How did you get an Australian-based EPD on these products, or was that?
So it's a global EPD.
Right.
It is an EPD that's done internationally, but we have confidence in the peer review of that particular EPD.
Okay, and that's how you were able to work out the tonnage or the kilograms of CO2, trusting the materiality. And your baseline BAU, how did you break that up?
So that's actually done by my colleague Kira. She's an LCA specialist, and that's really her cup of tea, is actually figuring that out.
So specialist.
I can't go into the details, unfortunately, but
No.
That's an in-house piece of capability that we have to track the carbon intensity of our buildings and building elements. Sorry, I should actually expand here. So Alcoa, Hydro Reduxia, and Hydro Sacal, they're actually European products, those particular items.
I had two more questions. I'm just going to keep asking.
Yeah, keep going.
Until someone cuts me off. Facade rate, you said they were pretty much like for like. You kind of got a percentage uplift. There must have been an uplift, I'm sure.
On the third tower?
Yeah, there must have been a small one, even if it was minor.
I think there was, but it was close enough to negligible that we just sucked it up and we went for it. I know that now in future jobs that we are working on now, where they're in the middle of the procurement process, they are coming back cost neutral now.
Okay, good.
Yeah.
And then the last one on the back of Jeff's, we share everything. It would be fantastic to get a bit more of a deeper dive on that supply chain, who you talk to, and that breakdown of the BAU, because we are exactly trying to understand how we show our reduction targets and create impact. But our baseline is going to be, working with other LCA people to actually come up with that number. So if it was possible in some way to share, I guess, this IP, but in this forum, it would be really helpful for all of us. I'm sure.
I'll see what I'm allowed to share out. I'm sure it won't be an issue in this forum, but I'll go and see what I can get and what I can share. But my key advice was that because Kira is our lead technical specialist in this space, having an LCA specialist involved is absolutely key in being able to understand our BAU baseline and be able to sort of create that view on what good looks like and what great looks like.
I think the challenge, Shen, is that certainly in the curtain wall market, our supply chain runs through China. Certainly, other glass and aluminium markets have opportunity to do things locally, but in the large monumental curtain wall market, the supply chain runs through China. So we've had to reach back up through our contractors to their suppliers and say, hey, this is the new business as usual, guys. This is what we've got to do. And you're talking to them in a language that Megan and Kira understand, but as an old facade guy, I'm kind of struggling with all these acronyms that these guys deal with. And then you're trying to communicate that to a supply chain that may not understand the acronyms and may not understand what you're doing. So full credit to Permis de Lisa. It was a real learning journey for them as well. And it took 3 buildings to get to the point where they went, okay, we know which rock to look under now. But the more we push and the more we find, the more products we are finding. We've got many, many more products now. And we've got a couple of other projects now that kind of, whilst I can't prove it, where we know that we've got the right stuff and we're doing it cost neutral because you keep that market pressure on the procurement process, as Megan suggested. It's just bringing the market on a journey and saying this is a new metric.
If we were to put this into our spec and we'll give our builders 6 weeks to price, are we just creating a rod for our own backs that we need to help more? Because I'm just thinking, we got a tender process, we got 6 weeks to procure, we get a competitive tender, we get yourselves, we get Maltese, we get whoever to bid, and then we go, oh, by the way, you've got to use HydroCal. Everyone's going to just look at us and go, that's not enough time.
I don't know that it's easy to nominate a product. I think that will take the competitive edge out. But I think, yeah, go, Megan.
Sorry, when we tried that on Tower 2, we tried to nominate the product, and that's kind of where we fell over because it just wasn't available. So we moved in Tower 3 to specifying a carbon intensity. I think the number we specified we weren't able to achieve, but we still achieved a significant reduction, but we went in and said, look, you know, we know that BAU is about 18 kilos per tonne. We want a product that's about 10 kilos per tonne. Go and find it for us. And that actually opened up a lot more opportunity to finding, you know, flexibility within the supply chain back upstream.
Because the opportunity is to push the supply chain to actually go and look and find what products are out there. And the more we engage with the supply chain, the more we find. The problem that we have in Australia is because our supply chain goes through China, our numbers are much higher. Our European colleagues are, you know, lower than where we are because the supply chain isn't running through China. There have been some restrictions of trade issues with some suppliers not wishing to sell their material into China. And that sort of crosses them off the list before you start. So it's really about saying to the contractors, guys, there's a flag on the hill. It's 10 or it's 12 or it's 8 kg. You go and find it because we know it's there, but you're a better chance of finding it than we are because that's actually what you do. I see there's some hands up, Jeff.
Oh, sorry, I can't see the screens.
I just noticed that, Jeff.
Yeah, I think Matthew was next, and then Angus was third.
All right. Actually, if it's all right, can we come back to that? Because I'm just conscious of time. Michael O'Keefe, his slides are coming up, and he needs to leave by 2:30, and his section's coming up. Is it all right if we kind of come back to this?
Do you just want to
that's
put the questions in the chat, and we'll answer them in the chat.
Yeah, thanks. I'm not very good at multitasking with chat and other windows. I've only got 2 screens. So, yeah, Michael, you're still around, hopefully for the next 10 minutes or so.
Yep.
Okay, so just kind of to Shen's point, you know, like around what's happening in Australia, I thought we'd just start to touch on that a little bit more. I think, you know, there's certainly been, from what I've seen, a really marked increase in media coverage, awareness, and announcements over the past year. You know, these are just some of them, you know, from the announcement between Capral and Tomago Aluminium on Australia's leading recycling agreement, to the federal and state ministers visiting key smelting plants and signaling the government's shift and focus on climate issues, and, you know, to research initiatives from leading circular economy consultants and our own working group members, Corio and Deloitte, on Australia's vast, you know, opportunity for low carbon aluminium and a circular future. Not all is new though. So Rio Tinto's Bell Bay smelter in Tasmania and their New Zealand smelter on the South Island have been running on hydroelectricity for several years, or many years, and do offer a local option for low carbon aluminium. Again, if you can get your hands on it, it's, you know, usually tied up in kind of long-standing procurement agreements. And also more recently, Tomago Aluminium, our largest smelter here in Australia in the Hunter Valley, which is owned by a consortium of Rio Tinto, Alcan, Gove Aluminium, and Hydro Aluminium, the people we were just talking about with the Reduxa and Circal products. They've committed to running fully on renewables by 2029. They're currently out to market for proposals, and I think they'll really play a key role in the Hunter region's transition away from coal to more sustainable technologies. And finally, before we get to Michael, Rio Tinto has also made a similar recent announcement for plans to develop over 4 gigawatts of diversified renewable energy supply and technologies for its Boyne smelter operations up in the Gladstone region. So safe to say, I think there's a lot happening in this space here in Australia, thankfully. I'd now like to hand over to Michael O'Keefe from Capral Aluminium. Michael is the general manager in marketing and technology at Capral, and will take us through some of their own recent developments. So again, Michael, happy for you to just tell me when you're happy to flick to the next slide.
Yep, thanks. Thank you. Good afternoon, everybody. just going to pick up on one of those earlier comments there. I'm talking about the supply chain going back up from China and asking those particular business entities to start looking for the right products. One of the most powerful ways as an industry we can look to do that is we can start asking those Chinese smelters, which are the ones that are producing the logs, or more importantly, those Chinese extruders that are extruding the sections for the curtain walls. We can ask them to start to procure from ASI certified smelters. So that's Aluminium Stewardship Initiative certified smelters. So for a smelter to be a member, an accredited member under the performance standard of ASI, they have to be certified to be smelting at less than 12 tonnes of CO2 emissions per tonne of aluminium. So straight away, you're getting a significant reduction on what is typically a coal-fired smelter without those regulations. That could be anywhere between 16 through to 24, depending on how dirty that particular smelter is, or how dirty the particular coal is they're burning to fire those smelters. So that's a huge step in the right direction, is to specify in your procurement plans ASI certified smelter procured aluminium. Okay, so Capral heard all of this noise in the built environment for a number of years now, and 2 years ago we embarked on a sustainability roadmap inside Capral, which has 4 components. Those 4 components, very briefly, are just reduction of energy, of course, reduction of waste, because we're very strong supporters of the circular economy. Additionally, recycling, and the last one was sustainable procurement. So today is very much about our sustainable procurement initiative. And one of the first things we did this year was enter into an agreement to Tomago to start to remelt and recycle our post-production scrap. So post-production scrap is where Capral extrudes all of its shapes for either the built environment or for the industrial, marine or transport sectors. And that post-production scrap, which is perfectly clean, perfectly alloyed scrap, will go back to Tomago, gets remelted, ends up back into, in Tomago's case, ends up back into aluminium billets, which are the telegraph pole lengths of aluminium we use to put through extrusion presses to make curtain wall extrusions, etc. And that's our first 550 tonnes in 2023. We're continuing to expand this particular initiative at Tomago, because Tomago does have capability to potentially take all 15,000 tonnes of Capral's post-production scrap and really drive that back into recycled aluminium content. In Australia, recycled aluminium content seems to be at a lot of people's first question in our particular area. And that's predominantly because you see a lot of aluminium being recycled in things like cans and other parts of small areas of aluminium. But mainstream recycling in Australia is very low and has enormous potential. About 95% of aluminium scrap goes offshore for remelt, and very little, as you can see, is onshore. But it's a massive opportunity for Australia when producing a local supply chain of low carbon. Thanks, Jeff.
Yep.
So part of our initiative was looking into our own procurement practices and taking on board all those earlier wonderful comments about supply chains in China and procuring low carbon aluminium. And I agree with you all, one of the hardest things to procure into China, to a Chinese extruder, is low carbon aluminium, because it would normally come through the Chinese Metal Exchange rather than the London Metal Exchange, which is more European based. So predominantly in China, you are getting coal-fired aluminium log or billet to go through the extrusion presses, unless you're lucky enough to be able to get it from Europe into China, which from an import duty perspective is very, very difficult to do. So hats off to Lend-Lease for actually pulling off that one of those towers. So Capral saw this real problem in the market and decided to act. And we've been working on this one for a good 12 months or so. And in November, or rather October this year, Capral released, the end of October, its new offer to the market known as Low Cal. We called it Low Cal for a number of reasons. We've also been on the trail of locally manufactured. There's, I guess, a little bit of anti-Asia sentiment through the pandemic, and a real indication of procurement coming back on shore over the last 3 years has led us to brand and market a product now known as locally manufactured and low carbon aluminium. So carrying the elements table there in number 13. So Capral released to the market this year Low-Cal Green, which is an ASI certified smelted log, which we extrude and produce aluminium extrusions at a CO2 emissions level of 8 kilograms per 1 kilogram of aluminium, or 8 tonnes of CO2 emissions for 1 tonne of aluminium. And that's predominantly gas-fired. So whilst it still comes from a fossil fuel, it's interesting to note that gas-fired aluminium is about 50% less than coal-fired aluminium. And then you come across to what's called Low-Cal Super Green, which is our certified ASI smelted aluminium at 4 CO2 tonnes of aluminium per 1 tonne of aluminium. We took it to market using the kilograms because we did a little bit of market research that people tend to assimilate with a kilogram more so than a tonne. When you talk to people about 16 tonnes as the industry average of CO2 emissions to 1 tonne of aluminium, I think that makes them run a mile from aluminium. So we wanted to just soften that message a little bit by talking to the industry on kilograms. Additionally, inside a business like Capral, you talk about kilograms of aluminium from a pricing perspective. So we promoted this kilogram. And interesting to the commentary I heard earlier on today, the Low-Cal Green aluminium has an uplift of 0 cents per kilo. So Capral does not charge a cent more for the green aluminium. However, the super green, which is hydro powered and comes from Tiwi Point, to Jeff's earlier commentary there, from New Zealand, that is hydro powered. That does carry an uplift premium of about 50 cents a kilogram. So as you can see on the screen there, from November 22, Capral now offers both of those products to the local supply chain. We, as you can see, the logs there, the telegraph poles I talk about on the screen. So we have all of those logs in all different shapes and sizes that either carry CO2 emissions of 8 tonnes per tonne of aluminium or 4 tonnes of CO2 tonne per aluminium, and we can drive those into any one of the projects that were specified in those particular types of CO2 emission levels. Thanks, Jeff.
Hey.
And like any good initiative, it's got to be underpinned with a level of credibility. So Capral is now a member of the Australia Aluminium Stewardship Initiative. We're currently going through the process of auditing and accreditation to what's known as the performance standard, and additionally the chain of custody standard, which is where we become certified to a sustainable procurement and sourcing of aluminium on a worldwide basis.
Okay, I think that's the end of the slides there, Michael. Thanks very much. I think that's really incredibly exciting news for the construction industry here in Australia. And really thank you so much for Capral's commitment to advancing our low carbon future here. I know you're probably pressed for time. I don't know if you've got a couple of minutes, if there's any questions on the line for Michael. Does anyone have any questions?
Excuse my croaky voice this afternoon. I think it's just about to figure out on me. But yeah, happy to take any questions at all in relation to that.
Michael, what's the market uptake? What's the market saying? Are they running the door down, or are they going, we don't know about this? And if they're not knocking the door down, what do we do to change it?
Yeah, it's a great question. They are knocking the door down, and they've been knocking the door down for a couple of years because Capral's heavily involved in not only the built environment, but also in defence, marine and transport. We've been getting all the procurement officers and procurement departments from all of those particular industry sectors talking to us on an ongoing basis about what is our CO2 emission position, what's our scope 1 and scope 2 reduction plans, What are our scope 3 reduction plans? So it's been a lot of noise for a number of years. And since we released the low cal and the low cal green, we've received just last week a very significant order from Austral Ships, who have been very focused on obviously government contracts on offshore frigates and things like that. And they are also focusing very heavily on the emissions intensity of what they're building in the way of marine vessels. And to pick up on one of Jeff's earlier comments, following our last deep dive, Jeff, with the facade contractors, we've been approached by the Atlassian architects, I think, built to talk to them about potentially local procurement of super green aluminium for that particular Sydney project. So, yeah, the phones are ringing. Our national specification team, of which we have 5 that interact with architects on a day-to-day basis and facade engineers on a day-to-day basis, their phones are ringing hot, wanting to know about a local offer for lower carbon aluminium within Australia.
That's great. Good on your architects.
Yep, absolutely.
It just reinforces Shen's question earlier that, you know, where do we generate the need? And I think the need's going to be generated by setting a target, you know, specifying a target, and the market will go and find the product. But we need to be specifying the targets and not walking away from it, regardless of, well, you know, where the supply chain is running.
Yeah.
When we change the metrics, we'll change the outcome.
Yeah, absolutely. And, you know, I mean, Capral wants to be able to offer this to the built environment locally in Australia, but we're also very conscious that over the last couple of decades, you know, the very high-end curtain wall industry has moved offshore, predominantly because of us. And that issue has predominantly closed down a lot of the capable facade contractors in Australia, and it's all brought in overseas from Perma-Stelesia and Uganda and these sorts of guys. And you know, they need to be challenged to be supplying lower and lower carbon aluminium in those projects. And the pleasing thing is that China is now investing significant funds into recycling. So they'll go low carbon out of China through their recycling activities, probably more so than they will for their energy generation activities. But the message is certainly getting through, and the uplift in price is very, very minor. It's the manufacturing costs that has been the driver rather than the procurement of the log.
Anyone else before we move on and say thanks to Michael?
Yeah, I had a quick one. Apologies.
Yep.
Mike, thank you. Thanks for the presentation, mate, and thanks for you guys sort of jumping onto this one. Tricky for a client, I think, to specify the smelter, but willing to consider that. I think definitely specifying the target is definitely on our radar, but specifying that next level down to the smelter would, and that's probably my question. You've mentioned ASI. Are there other comparable, I don't know, group standards that we need to consider if we don't want to fall into the trap of sort of, you know, anti-competitive sort of tendering or pushing subcontractors to force them down only one or two sort of routes in terms of their supply chain, because we know so little really about that chain of custody all the way down to the actual ingots. It feels like quite a stretch for a client to put their neck out on that versus maybe a builder doing that.
I don't know whether it's going to actually be that difficult for us as an industry, because there are now over 250 members from ASI. So the vast majority of smelters in Europe and more and more smelters in China are becoming ASI members. Rio Tinto is an ASI member. So you're going to find that the ASI membership is going to become quite global, and just that in itself is going to start to drive the piece of aluminium that goes to an extruder to become your curtain wall is going to start to come from sustainably sourced supply chains just by default. So I think asking your facade contractor to check that the log or the billet, as we call it, is coming from ASI smelter background, I think is the way of the future for us. If you do a little bit, if you jump onto the ASI website and have a bit of a look around, you'll see that all the big players, the Rusals and all the ones that were on that list before, are all able to smelt below 12 CO2 tonnes per tonne of aluminium. So the vast majority of all of those guys are already members of ASI.
At the risk of saying something a little bit controversial, I'll preface it by saying it's an Angus Gordon comment, not a GPT comment. I probably slightly disagree, Shen. I think it is the client's responsibility, and I think maybe that's why it is so difficult to drive change in our industry, is that I think for too long as clients, we have passed on the responsibility to our contractors and subcontractors rather than owning some of these responsibilities ourselves. And I think the push to actually deal with upfront embodied carbon is a really great opportunity to take on that inertia in our sector. And if we did that as clients, we get much better product and outcome for our buildings overall as an end result, not just lower carbon buildings as an end result.
Yeah, completely agree. And it has to be driven from the design and from where we all sit, because if it's not, it's going to come down to the lowest cost. So unless there's a sustainable initiative driven into the ethos of that product, the building design, it'll get weeded out on price.
We've got a procurement methodology that really outsources so much to others that controlling our own end product is a challenge for us. And it's worked for decades, but I think there's a number of elements that are actually challenging that paradigm. And if we're smart about it, it can be a great opportunity for change.
That's a really interesting point, and I think maybe what you're alluding to is probably coming up in our next section on procurement. So if you have any more thoughts, I'd really, you've done exactly what I wanted you to do.
That's an Angus Gordon comment, not a GPT position.
Okay,
so
all good.
Jeff, I'll just close in saying to the group today that if you wanted to research more into this space, there is a couple of new websites that are up. lowercarbonaluminium.com. If you were to go there, you'll see a whole lot of information on white papers and technical information on ASI, on low-cal aluminium, and the partners that are in play there. So that's lowercarbonaluminium.com.au or just .com. They're both domains are registered, and that'll help you have a look around. And Capital's happy to help with any inquiries. So you can come back to MECLA to us, and we're happy to help you out with anything that you would like to do on this journey. That's it from me.
Thanks very much, Michael. Appreciate your time. I know you got to go.
Pleasure.
Speak to you soon.
Cheers. Bye, everyone.
Okay, so that was a good little segue here. I have some notes to say that I obviously really welcome all your contributions, even if you feel a few points may go against the grain a little. But Angus, you've already opened that door, so thanks very much. We're going to talk about a few things related to procurement, but I thought we'd just kind of start with and finish off on cost. Obviously, some of the commentary from Lendlease and Capital have taken a little bit of my thunder, but I think it's always fun to hear an architect talk about cost. And luckily, I think the research that I'll kind of share with you that we undertook separately does sort of back up really what Michael and Lendlease were sharing with us. So the research that we did was really just looking at the major metal exchanges. So as you know, or was mentioned, aluminium, like all metals, is traded on the market per ton. And this graph shows the fluctuation in price per ton over the past year to date, ranging from just under $2,250 a ton upwards of about $3,750. And obviously that graph over the past year represents what we've all known and experienced to be quite a volatile one. And as you can also see in the quote from a recent article, a market article looking at the price premiums between purchasers and suppliers, An average of about $30 per ton or more was the expected premium that you would typically pay for a low carbon aluminium. So interestingly, that represents just a 1 to 2% uplift over the base cost of the raw material itself, which I suppose really backs up, what we heard from Lendlease and Capital. So it's not as simple just as saying that, we heard on a MECLA call that this stuff doesn't really cost anymore, and certainly not double. But I hope that this does, assist in helping everyone think twice and ask again the next time you hear that low carbon aluminium is price prohibitive. And just thinking back also to an earlier slide on what is low carbon aluminium, this version of that slide illustrates a bit more detail around some of the average carbon intensity you might expect out of China, Australia, or even more globally. So in the middle there, it shows an average for virgin aluminium produced using hydroelectricity of around 4 tons per CO2 per ton of aluminium, and that's kind of the super green stuff that Michael was talking about coming out of Rio's Tiwa Point in the South Island of New Zealand. And then right down to some of the world's leading recycled products out of Europe, as low as 1 kilogram or ton per ton of aluminium. And this is the EMAX, the product that actually was supplied for the Masdar project I mentioned at the beginning. So yes, low carbon aluminium does already exist, as we've heard multiple times. It's here in Australia, and particularly with Capral's recent announcement. And these are just some of the well-known producers available on the market today. And a lot of these, if not all of them, just doing a quick check, I believe are ASI certified and accredited. But if we're working on projects that are procuring from overseas, the real challenge is how do we get our hands on it for projects in Australia? And I think that's really why we have to start the conversation early. So, to Shen's point, if we have a 6-week tendering process, that may be a bit too late until the point at which the market becomes a bit more mature in these conversations and it becomes more of the kind of, business as usual. But at this moment, that's probably leaving it a bit late. I would also argue that many of us don't really fully appreciate where our stuff comes from, with the complex facade packages of upwards of 30, 40, or even 50 different suppliers and subcontractors. The difficulty we have in understanding where everything comes from is even more challenged. So the kind of questions I think we need to start asking on our projects are, do you know, or Mr. Supplier, do you know where your aluminium comes from? Or how far back in your supplier's supply chain do you have visibility? And if you don't have visibility, what can we do to increase that? And so what exactly are the challenges in procuring this low carbon aluminium? I think the first real challenge is that the industry is just starting to look at this seriously, and anytime you do something for the first time, it's never going to be easy. So yes, supply may also be an issue. Many of the large extruders and facade manufacturers lock in large annual or multi-year supply agreements. If they haven't purchased a quantity of low carbon aluminium already, the chances of doing so, again, within the timeframes of a typical project's procurement may be an obstacle. But this is exactly why we need to start our conversations now, ideally outside of a single project, and send a strong demand signal to the market that this is something that is important to us and we need to address. And one thing I think we're all aware of, as we've obviously clearly been discussing, is the role that China currently plays not only in aluminium production, but in facade manufacture for our region. But this is not something that we should simply hide behind and say it's too hard. Thinking back to the graph I showed earlier, on average carbon intensity of aluminium by country or region, China, was at the top of that list for a reason. And that reason is that currently 80% of the aluminium produced in China uses coal-fired power, many of which are captive coal plants for the smelting plant or plants within that particular region. However, the Chinese government, as Michael also alluded to with other recycling initiatives, they have understood the impact their coal power stations have on the climate and their own environment. and they've sought to move as a really significant proportion of their smelters to other southern regions where hydroelectricity is in much greater abundance. This has already happened. I think this was starting to happen nearly a decade ago. And the point really being for us is that there are options for low carbon aluminium in China or wherever you, procure your aluminium or facades from. And just as one example, there's a consultancy firm, Wood Mackenzie. They've produced a series of asset reports on nearly all of the Chinese aluminium smelters that outline their ownership structures, their power supply sources, the intensity of their aluminium in terms of emissions, and their annual output capacity. As shown on the slide here, this particular report identifies a region of smelters operating on hydroelectricity that produce over 3.1 million tons of aluminium per annum. And if we compare that to Australia's total production of 1.6 million tons, 90% again, which we export, I think you'll see that if you ask the right questions, to the right people and early enough, I think there is a possibility we'll find that solution. And possibly to Angus's point earlier, I think this conversation is broadening and not just about embodied carbon, but about much broader issues about our very complex and global supply chains. It's not just the things that go into our buildings, but I'm sure very few of us are really deeply aware of where our things actually come from and the impact they have on the environment or the people that are involved in that particular supply chain. And this is not an isolated issue. Forms of modern slavery exist in nearly all countries, and a lot of the contribution from our working group member, Sebastian Lowenstein at the Clean Energy Finance Corporation has really centered around this topic. So as a federal investment body, the CEFC looks to help finance projects that will help deliver on our low carbon future. And one of their key investment criteria is supply chain transparency. And I'm sure many of your companies would also be familiar with the TCFD framework for quantifying and disclosing climate-related financial risks, which also includes measures around modern slavery. So it's an important topic that is complicated and involved, but again, I think also tied to this conversation and having much more focus on it. And now very, very quickly to kind of wrap up and maybe open it up for some questions and answers. What can we do as an industry or as owners and developers? What could our role be? I think, well, there were a lot of things discussed in the call today, but I think one of the greatest things that you can do as Australia's largest, developers, or one of the largest, Australia's largest developers, is to send that clear and strong demand signal to the market that low carbon aluminium is important and necessary for decarbonizing our environment. As owners and developers, I think you all have a huge role, not only in creating the projects we all work on, but also to set their ambitions and goals. And pushing your consultants and pushing your contractors to say this is important to you will go a long way in creating that market demand signal and accelerating our low carbon future. One of the other key takeaways for me is that it's really is also about asking questions, particularly of your supply chains, again, as early as possible and ideally before the program constraints of a single project take hold. So like the lessons from Lend-Lease case study, we need to be persistent and likely expect that the same sort of initial replies when we ask the same questions of ourselves for the first time in our own projects. And finally, I think one of the biggest things we can do is to work together, not just as consultants and clients or clients and contractors, but also acknowledging that often, the roles we have maybe have very different drivers behind them that sometimes seem at odds with each other. Obviously, some roles may be more focused on delivering on cost and time, while others are more solely focused on achieving sustainable outcomes. And I guess that was really the intent today of trying to have both development managers, design managers, and ESG managers on the call today. One of the discussion points that came out of our previous consultant deep dive was that from the consultant's perspective, sometimes the client's sustainability targets or ambitions don't always seem to come through in the day-to-day experience or running of the project. So sure, there are realities that some of these sustainability goals may challenge a project's time and cost parameters, but I think working a bit more closely together may help solve some of those issues. And I think, you know, from my own personal perspective, that's really starting to come through a lot more on the projects I'm working with. So that's all we have to run through today. I hope you all were able to take something away from the session, and now I'd really like to open it up to the floor for some Q&A. Would anyone like to start off while I bring up the questions from the chat? I might just stop sharing my screen.
Jeff, how much of the presentations are you going to share with this forum? Are you able to share?
Yeah, that's a good question. I am able to share. I haven't put the slides up themselves on the MECLA website, but very happy to do so. So all three of the sessions have been recorded, and I'm happy to put the corresponding slides with each up. I mean, each of the presentations is nearly the same. They're just tailored to the particular audience. But yeah, I'm really happy to put the slides up as well.
I mean, what was fascinating about that, Jeff, was by the sounds of it, if we were sophisticated enough and engaged enough, we could already getting the reduced carbon aluminium out of China today, because they've been making it for a while.
Yeah, that's right. So that was kind of an eye opener for me.
Yeah.
I mean, those reports cost about $2,500 per report, which I wasn't willing to pay. But there are a fair few of them out there, and you read their summaries, and it's certainly, from what these reports are saying, seems that it is available. So again, it's just like connecting the right dots and asking the right questions, I think.
Jeff or Megan, just a quick maybe comment or statement. I think to have maximum impact in this area, we need to hit the middle of the market or even the bottom of the market. It's not just the top end of town that need to. I mean,
Yes.
we'll lead by example, but how do we hit you know, the mass production? I know One Sydney Harbour, I worked on that many years ago, and the cost budget for the facade was fantastic. So you can sort of move things around when you've got a healthy budget and make it work. And I know, you know, we've said that it's cost neutral, but you know, how do we hit those $1,200 or $800 curtain wall facades that we're seeing in Melbourne and Brisbane and the like, not just Sydney? So I think that's more you know, comment or a challenge for all of us, not just to think about the top end of town. How do we roll this out for everyone?
Yeah, that's a really good point, Charlie, and that's certainly been a big discussion within our working group. You know, we did have, and we kind of keep knocking on the door of G. James. They were in our group originally, but acknowledging that, you know, the market is very different at those different scales. So Matthew Finn, I'm not sure if he's still on the call, but he had put together a really good kind of summary of the larger facade subcontractors, the medium scale and the small scale, kind of where they manufacture their product from. And it was really interesting. So yes, there is a lot of stuff that gets produced here locally in Australia for the smaller, particularly resi jobs, where it's more measure and cut here that can't, for those reasons, be done off overseas. So that has been certainly a topic of a lot of discussion in the group. I suppose for these calls, given that we were targeting, you know, the likes of yourselves to be on the call, a lot of our experience is in that range of projects. So that's kind of why the document and topics have focused that to that side of things. I'm not very good at reading these questions, but so there's a question from Matthew Kelly regarding the graph on the embodied carbon aluminium versus other building products. What was the total reduction in embodied carbon to achieved in the project as a whole? And what percentage was attributed to aluminium? That might be one from Megan. I'm not sure that you'll know off the top of your head what was the percentage reduction for the building as a whole.
Yeah, so I answered that a little bit further down. Using the
Oh,
34% reduction of carbon intensity product, we achieved a 5% reduction in the carbon intensity of the whole building.
All right. Yep. So there's another question from Sarah. She's based in Perth and thinking that it's worth raising that most of the bauxite mines in the southwest forests of WA are looking to expand operations currently, which has a huge impact on the northern Jarrah forests. The knock-on effect is deforestation in an already threatened biodiversity hotspot. Absolutely. I had another section of the slides which talks exactly about this, which I don't have. Sarah, are you still on the call? Possibly not. If anyone wants 5 minutes, I've got slides to talk exactly to this point that kind of makes you think about what we're doing. Does anyone else have any kind of questions or topics you'd like to raise?
Hey Jeff, I think yeah, Angus made a good point about us and where we have to push. I need to know all of the, I guess, the detail before I jump. And so everything you guys have done is fantastic, and being able to just understand groups like the ASI, the information you put up about, you know, there's already a lot of these materials available. Why haven't they used them? That all of that stuff, if it's bundled together in the right way, we can very quickly sort of start to adapt into our plans going forward, knowing that there's, you know, multiple chains of supply, multiple competitive avenues, and then we can set the targets. I think the more of that information that's available to us as the clients, that our engineers can bring to us, that our builders can put in front of us, etc., we can have that information, the better we'll be able to justify internally on a risk basis that there is no risk. This is just about having the willingness to actually put that in the spec and getting the supply chain to actually deal with it. And then when they struggle, if they do, or they're a bit lazy, we can point them to the right sources to find the answers for themselves. As you say, maybe the biggest one is that they've set up a 20-year contract with the supply chain and they don't want to break that. But then, you know, all we can do is ask.
I think, Shan, the way to guarantee that is to, for people like Investor and GPT, I guess, is to say, what is a reasonable target? Where do we want to start as a reasonable target? Let's specify that. Let's start getting that in the parent hierarchy of documents all the way through, and let's start pulling it through. It's there, it can be had, but if we use a target as opposed to nominating specific suppliers, that allows us to keep competitive tension in the process for as long as possible. And the secondary benefit is we learn more, we find more on the way. So I guess I'd be encouraging that.
I can see Matt's jumped on. That's exactly how we're looking at approaching on a project we're working on together.
Yeah, I think it's some of the common themes with the like you maybe specify a smelter or specify these targets or something. I think the reality and the complexity with facades in comparison to concrete and steel is that D&C approach and the lots of bits and pieces kind of all coming together. And this approach where you say specify a reduction from a reference panel is, if you say reduce it by 20% or reduce it by 40%, the reality is that the only way that they can achieve that is through aluminium, is through responsible sourcing of aluminium, because aluminium makes up such a big component of the facade. So maybe by specifying a target or a smelter, it's kind of the same thing, because the only way they can really affect it is by touching the aluminium. So yeah, this is why Angus and I were discussing, maybe we specify this kind of benchmark facade performance, and they can affect that by either touching componentry, whether that be glass or aluminium. But in reality, aluminium's the low-hanging fruit, and that's kind of the easiest one to affect.
That's actually really closely aligned, Matthew, with something that we're trying to do in some of our upcoming bids. Is really specify a facade surface area carbon intensity target, rather than saying percentage reduction in specific materials, because it helps the supply chain really drive all aspects of the building system downwards. And it just happens that if they're going to achieve it, they have to do something about aluminium. But it also, glazing glass is the fourth biggest contributor to upfront carbon. It really helps, drive more than just the aluminium conversation.
Yeah. So something we're doing at Arup is we're sort of mapping reference buildings in Sydney to see roughly what CO2 per square metre those facades are. So we've got some good benchmarks to show clients. And then what are we going to specify, and is that kind of achievable or not achievable? And then the third component into that is to generate a way to calculate it and to have some sort of a comparative number. So someone's not inventing some kind of calculation method or sort of tweaking the numbers. And the CWTC just published a kind of calculation method, which is kind of a global document around how to calculate embodied carbon in facades. So the potential, we might sort of specify that document as a way that you must use to calculate the embodied carbon in your facades.
I think the other key question.
It's a cracking document.
Yeah.
So I just say that the CWCT document was put together by some really clever people, and I'd really support the use of that document just so we've got common benchmarks. It's a really great starting point. I'd really support that, Matt.
As I say, I think the key challenge that then also comes out of that is how we, collectively get a lot better at actually taking the outputs of one project and getting that as the baseline for the next project. I think too often with our projects, we start from scratch again, and we ask the team to go out and do the same amount of work, same type of work that we did with a different project team 2 projects earlier. We haven't taken the learnings, shared them, disseminated them, and made it the base for the next project, so that we're already starting at that sort of next layer of performance before we try and, drive improvement again.
Absolutely. Just conscious of time. Any last comments or thoughts? If not, I may just whip through this this little segment here, even though Sarah's dropped off the call. This will be very quick, I promise. I will run through it. So it's called For What It's Worth, and essentially the guy on screen here is Dylan Marsh. He's a South African photographer and artist. He was really taken by the impact that disused mines in South Africa kind of left on the landscape. And what he did was went around photographing all sorts of different mines, from copper to diamond to platinum and other mines. And then through researching how much material was actually produced out of that excavated mine, worked with a visual CGI artist to represent that amount of material in some form. So here you can see 4.1 million tons of copper, represented by the copper sphere here in the middle, sitting within this vast Palabora mine. And the title of these series of artworks are called For What It's Worth. And that got me thinking about bauxite. And like Sarah said, that it's scraped up on the land. They're dumped into massive trucks like this and moved around, processed by massive machines like this that get dumped onto trains, taken to port. And again, as we talked about earlier, shipping the vast majority of our bauxite overseas. But when you kind of start to look at that, and I mentioned what a big player Australia is in this market. We have the world's largest bauxite mine up here in the Northern Territory at Weipa. And if you start to zoom in on that, you can start to see the impact of this surface mine for bauxite, what it has, getting closer and closer yet again. You can start to see how this kind of sprawling surface mine, where they scrape it up from quite just below the surface of the earth, how it starts to expand. And if you zoom in again, you get the kind of sense of scale really keeps to unfold. But what we're looking at here, and inside that last square, is actually one of these trucks. And when you see that kind of the gravity or the scale of those operations, it really makes you think that the next time you have one of these, or as an industry we work together on one of these, we should all remember what it's worth. So unfortunate that Sarah couldn't join for that little bit, but that's something that sometimes I share with a few other groups, and I think is, talks to a few other things that are also a part of this conversation that we didn't get to today. So that's bang on 3 o'clock. I'm happy to wrap up there unless there's anything final, but really I want to thank everyone for joining today. There was a lot of great conversation there, and appreciate it so much.
No, thank you. That last bit was very revealing.
Yep.
Thanks for hosting.
Thank you.
That's fantastic.
Right.
Thank you.
Thank you
Bye-bye.
so much.
Thanks very much.
Thank you. Thank you, everyone.
Thanks, guys. Take care.